Have you ever wondered why time seems to flow in one direction? It's a question that has puzzled philosophers and scientists for centuries. One fascinating concept that helps explain this flow is entropy, a fundamental idea in physics that relates to disorder in a system. Let's take a closer look at how entropy intertwines with our understanding of time and why it feels like time marches forward. Firstly, entropy is often described in the context of thermodynamics, specifically the second law. This law states that in an isolated system, the total entropy can never decrease over time. This means that natural processes tend to move towards greater disorder. For example, think about a bowl of ice cubes melting on a warm day. Over time, the neatly arranged ice cubes mix with the water, creating a more chaotic state. This increase in disorder is what we refer to as increasing entropy, and it coincides with the passage of time. So, each moment that passes often corresponds to an increase in the overall entropy of a system around us. Now, let's connect that concept to the arrow of time. The arrow of time refers to the one-way direction in which time seems to flow, from the past to the future. This idea is rooted in our everyday experiences. We remember the past, but can't recall future events. Entropy plays a crucial role here because, as the universe evolves, it tends to move toward a state of maximum entropy. This progression creates a clear distinction between past and future. In a way, time moves forward as entropy increases, giving us a natural arrow that we can follow. Interestingly, some scientists have pondered what would happen in a universe where entropy does not increase. In such a scenario, time might not have the same directional quality that we experience. If everything remained in a constant, low entropy state, would time still feel linear? This speculation touches on deeper philosophical questions about the nature of time itself. By understanding entropy, we gain some insights into the fabric of time. Finally, let's think about practical examples of this relationship. Consider the everyday processes around us. A fresh cup of coffee cools down over time, moving from a high energy, low entropy state to a cooler, more disordered state as the heat dissipates. This is not just an isolated phenomenon, it illustrates a broader principle where time is marked by the increase of entropy, whether it be in the cosmos, a cup of coffee, or the aging of living organisms. In conclusion, entropy and time are deeply interconnected, with entropy providing a physical basis for the directionality of time. As we navigate our daily lives, understanding this relationship not only enriches our comprehension of the universe, but also reminds us that every moment is a journey toward greater disorder, marked by the passage of time. So next time you enjoy a cup of hot coffee, think of it as a tiny reflection of the grand time-entropy connection at play in the universe.